Codifying the configuration of legacy applications can be a powerful way to improve consistency, reduce manual errors, and make deployments more predictable. However, whether the entire configuration can be codified depends on the nature of the legacy application and its infrastructure. In many cases, full codification might not be possible, especially for older systems that are tightly coupled with specific hardware or are built with outdated frameworks. This type of legacy applications often have hard-coded configurations, dependencies on specific physical machines, or other constraints that make full automation difficult. But that doesn't mean we can't make significant progress by codifying the parts of the system that are more flexible or that benefit most from automation. So where do we start with codification? One of the most accessible starting points is the infrastructure that supports the legacy application. Codifying infrastructure means defining it in a way that allows you to provision, manage, and version control it. For example, tools that allow us to manage configurations through code can automate how servers, network configurations, and storage resources are set up and maintained. This ensures that the environment remains consistent across development, testing, and production. And in practice, this approach reduces the risk of misconfigurations that can occur when environments are set up manually. Additionally, codifying the infrastructure allows us to take advantage of version control. We can track, we can review any changes made to the infrastructure, ensuring that if something goes wrong, we can easily roll back to a previous version. This also helps to document the infrastructure setup, which is especially useful for teams managing complex environments. Next, we could also consider codifying key elements of the application configuration. While fully automating a legacy application might not be possible, smaller but critical elements such as environment variables, database settings, or external API configurations can often be codified. Managing these aspects through code allows for more efficient and error-free deployments. By automating deployment scripts, we can also remove a lot of the manual steps involved in rolling out updates or changes to the application. Even if the deployment isn't fully automated, scripting portions of the process helps reduce human error and can speed up the deployment times. This incremental approach to codification improves the reliability of deploying the legacy system across different environments. And so we say, what are the benefits of partial codification? The benefits of partial codification are substantial. Even if we can't codify everything right away, starting with what we can automate today, such as the infrastructure, environment configurations, and deployment scripts, allow us to modernize gradually while minimizing risk. For example, by automating the provisioning of environments, we reduce the risk of inconsistent configurations between development and production. Automating deployment steps simply makes it easier to test and validate changes in a controlled manner before they hit production. These processes contribute to a more stable, repeatable, and scalable system overall. Ultimately, codification should be part of a broader modernization strategy. The aim is to incrementally codify what we can now and over time extend automation further as the system evolves or as components are refactored. While full codification might not be achievable in the short term, starting with low-risk areas like infrastructure and deployment scripts sets a strong foundation for future improvements. In conclusion, codifying the configuration of a legacy application may not be fully visible, but by focusing on infrastructure, environment settings, and deployment scripts, we can take significant steps toward improving operational efficiency and stability. And as we modernize further, the scope of what can be codified will expand, allowing us to unlock even greater benefits over time.